Thank you for coming. And I was about to say good morning, but probably it's a good day already. Is it? Well, so the topic today is the facts about Kotlin. So I decided to collect some facts which might be interesting. Some of these facts are not that technical, others are. And before we start, I would like to ask you who know or something about Kotlin before? Wow, great. So, and who wrote some programs in Kotlin still? Oh, almost the same hands. Thank you. And who has the Kotlin in the production? Great. And is it the server side still? 0 hands. So actually, the Kotlin is a language. It's a general purpose language, so you can do it not only for mobile development. Hope you do iOS probably, but for all other developments like server side as well. But okay, let's start. And there are a few facts about me. So if you see me around, ask me or a question or say hi. If not, tweet me. I'll try to help you. And there's for my facts about Kotlin. I started using Kotlin at the times where to create an interface, we use a trait keyword. And it was renamed to interface but closer to 1.0 release. And it was yet another times where you did not need an init keyword to declare a constructor. Well, these were great times, and I've been trying to create IDE cells, and it was a surprise to understand that init keyword, it changed a little bit the way I designed my IDE cell back in the years. But never mind. So why Kotlin? And why Kotlin at JetBrains? So back in, I think, 8 or 9 years, we had at JetBrains an IDE, which is IntelliJ IDE, and several small IDEs for different technologies. We had an experience in creating languages from one side. From the other side, we've been looking for some good language to develop and continue to develop our tools. And by that time, the progress and the evolution of Java was pretty slow. And so we've been looking around. We did a try. We tried several different languages to see what is the best language for us to do. Some of these you can still find in the IntelliJ community GitHub repo, some of these languages. And well, to tell the truth, we were not able to find a silver bullet. And I'm not sure if it even exists in theory. So we decided to kick on an experiment. We decided to give it a try and create a language which would be the best for us at JetBrains to continue doing our tools, at the desktop IDEs, server-side tools, anything. So we started thinking and decided that it's good to have a language which is concise. So you no longer would need to write the code which you actually generate by an IDE. So it's better if you would be able to have a language where you don't need to write this, if it is obvious, if it is the copy-paste or automatically generated. Or it has to be safe. And in IntelliJ source base, for example, we tend to use nullable and not null annotations to clearly specify whether something can have null or not. By the way, do you try using the nullable annotations in your code base? Only a few hands. It's good to give it a try. It allows you to clearly specify where do you need to do the defensive checks, where you need to follow the Java docs and so on. And so that we decided to include this feature into the language. So in Kotlin, whether you declare something, you clearly say, okay, it's nullable. Fine. It's not null. Fine. And the compiler would make sure that all the places in the code base would have necessary checks. Because it's way better to find a null pointer problem or $1 billion problem at the very, very beginning, not at the end. So if you don't check it and you have a null pointer exception, that would be a crime scheme where you both the murderer and the detective to figure out why it fails with null pointer exception at that given point. Their interoperability. And again, it was clear by us, and I hope it's clear for everyone, that if you would like to give it a try with a new language, it's way better to use these languages side by side without stopping the world and rewriting anything with a new language. Of course, being a software developer, it's an amazing fun to rewrite anything. But as of the business or the company side, well, they may not be that happy about you rewriting anything with a new language, with a new bugs, right? So it's good, and we invested into the back and forth interop between Java, JVM, and Kotlin. So you can use JVM libraries, you can use Java sources along with Kotlin sources, even within the same module or subproject, even with a cyclic dependency between Java and Kotlin. So you can write new code in Kotlin and keep the old code base in Java within your existing project, which may, by the way, run with Java 1.6 still. Well, and the last thing, that's a feeling I have, for example. If I see a new language, and if I need to start doing it, well, it's way easier to start with a tool, because at least I know how the functions are named with the code completion and stuff. So we invested with a tool friendliness from one side. From the other side, by even 8 years ago, we had an experience in supporting different languages with an understanding what is toolable, which features are good for tools, which are not, which is not. So this was like an entry point, or like something we started from, and we created a language, and it was called Jet. You probably haven't seen it before, but in some code in the project files of IntelliJ projects, you may see some references to it. Well, and yet another thing about the culture at JetBrains, we tend to have the Jet prefix for anything we start inside. The Jet launcher, Jet registry, Jet food, and so on. The Jet food is there something where you have a food and meals in the office, right? It's not a software project. Well, and by that time, an experimental extension was Jet for this language. Well, that's kind of a culture. So this is the XML, the code style settings you may have seen in the .IntelliJ folder somewhere underneath your projects, which are pretty old. I think they finally renamed it to Kotlin back in the years, but still it kept here longer than the name. And they're somewhere closer to our first official announcement or discussions at the JVM Language Summit somewhere in 2011. The language was named Kotlin, and the extension was selected to be KT. And their logo on the right, this was the first logo of the language. Do you remember that logo, by the way? Oh, few hands. Great, you're with us. Well, then their logo was changed to this one, and their code name turned out to be their official name. It's the thing, so it was selected temporarily, and it's still here. It's a great name, right? And back in February 2016, their Kotlin was released. But these were the obvious facts in the prehistory, and I decided to go further, and I decided to search the internet to find something related to Kotlin. And I found this one. Well, now, when you're speaking with somebody about the platforms where you can apply Kotlin, you have a plenty huge set of features beyond the standard JVM, Android, iOS, and JavaScript development platforms, right? Tell them it. Well, the second thing I found so far was this. And I think I should go there and take a selfie because it's an amazing place. Is it? It's a real place. It's an existing place in this world. It's somewhere in the middle of Poland, by the way. So not far. It could be probable to get there, right? Well, fair enough with the geography for a moment. And by 2014, we created the Kotlin Lang website. With the documentation, information, tutorials, and so on. This site is existing, and it's a good place if you're looking for something about Kotlin. This is the place where you can find the answer. And this was the previous side, the very first side of Kotlin, and this is the second side. And this lighthouse in the picture is something which exists in the real world again. Here, it would be way more exciting. Yet another picture. And they probably have an idea where it is. Well, now I'll tell you. This lighthouse is on the Kotlin Island. And the Kotlin Island is not far from St. Petersburg, Russia. So it's not far from the place where Kotlin was initially started and being developed for all the time. And I'm not just saying this, I have even a proof. In this book, that's the Kotlin in Action book, written by Dmitry Zhemirov and Sveta Isakova, in the preface, it clearly explains that the Kotlin language was named after the island, which is not far from St. Petersburg office and so on, right? And even more, it was Dima Zhemirov, the author of this book, who took this picture from the website. Well, geographically, it's 32 kilometers from the JetBrains office in St. Petersburg. And okay. Now let's go a little bit technical. And let's have something more exciting. And a warm-up for you. So I've seen almost the whole room of arms saying and you use Kotlin, right? So this is an answer. This is a question for you. What would it print? Well, if you don't know or if you are not certain, try the play-kotlin-lang.org. This is the website where you could type in your program to experiment with, and actually you don't need an IDE. It would work even from a cell phone. Well, and if you see clearly, I've done a mistake here for purpose. So this is a real one for warmup. The question is, will it work? What will it print? Well, and let's debug it and explain. The first thing, the plus here is an operator. It means that you can navigate to its declaration, and you'll see something like this. Well, it's a good habit and a contract in Java. If you try to turn a null into a string, you will have a null quoted. It's even better than their possible situation where the application crashes if you have a null and you try to turn it into a string, right? It's better to see something visible so that you could debug it and fix it in a later. And it's so fun to see some email saying, hello, null. Oh, that's probably a problem somewhere in their side. That's why they send you and name you null, unless you named null, right? Well, and hopefully it gives you a hint to the answer to my question. So I would replace the plus operator with a function call like this. And we are almost here to see the answer. Well, wake up. This is a trick. But we are here not for a puzzlers session. That's why we'll fix it. So we can create a function with that kind of signature. And don't be afraid, this nothing is a type. This is a specific type in Kotlin, which has no values, meaning that the program should not go further, and the compiler knows that. The only way to return, like, you cannot return something, you can only throw an exception from a function which returns nothing. Well, and the compiler knows, and the compiler highlights, it says, okay, this plus operator would never go further, so fair enough. That's good, right? But it is not enough. And we may use a deprecated annotation in Kotlin. This is something interesting. In the deprecated annotation, you may specify the level. How would you like to have this deprecation work for you? And the most horrible, the most strong level is to say 0, so that the symbol is kept in the bytecode for backward compatibility, for example. But the new code would not be allowed to go through this usage. And in my case, I deprecated this plus operator with this annotation so that I would have the compiler error in all the cases in my program where I would try to have null plus null or null plus something expressions. Good, isn't it? So far, we solved this problem, and probably it would go into the standard library, I'm not sure. Well, before I told you nothing specific about nothing, but let's stop a little bit and figure out what is nothing and how it works. The nothing type in Kotlin is a specific type. It is kind of an imaginary one. It lives in a compiler, and it is a subtype by definition of any type which you may have in your program, no matter if it is a final type or not a final type, because you would never actually inherit it in the means of the bytecode level or Java. It's something we have in mind, right? And it has no values, so the compiler understands if you have a signature like that, it would mean that the function would throw you an exception. This is the only way to go. And you can use it like this, for example. You may create your function, which is your specific assertion. And if you call this one somewhere, like a crash or exit or something, like, or for example, in a unit test, you may create a fail function which returns nothing. And the compiler knows that beyond this point, it is not possible because an exception will be thrown, definitely has to be thrown, and an exception. And you can declare several more things which have the same type, like a return statement. Well, essentially in Kotlin, almost every statement is an expression of some given type. And here, a return statement has a type nothing, throw statement has a type nothing. To-do function, this is a function from a standard library which really helps to simplify the code you write. And I'll show you an example in a moment. And there your custom assert. All these types, all these declarations have the type nothing. And let us assume that we are working on some algorithm. And at some point, I need some functions to be implemented just to work on my algorithm. What I do, I declare these functions and I say equal to nothing means like return to do. And as long as I specify the type, the result type of the to do is nothing, which is a subtype of anything. So it's okay. It's okay to have it this way. And if I would call it in the runtime, I'll have an exception, which is fine because right now I experimenting and I need to focus on the algorithm I'm doing. And let us assume that I've created the following code base. And here's the thing. You see this gray highlighting over there, do you? Yeah, I hope you do. Well, if you see such a thing in an IDE, it means that there is something which you could improve. If you have time, of course. It's not necessary, but, well, for the sake of simplicity, you would consider clicking the quick fix action and say, OK, replace. I have no clue what it means, but I will say, oh, yeah, that's probably a good idea. Is it? If we do so, the whole line turns out to be the one line with the else operator over here, you see? Instead of have if something is null, you say else operator. So the left side is null, the right side is executed. And the resulting type in this sense is not nullable or info. We can apply this thing once more. And finally, we have this thing. So we started with a long code block, which you may have like in Java, for example, or if you copy-paste the Java source into Kotlin source, you would see something like this. And we can shrink it into something that short. It's good, is it? But the types of nothing helps us to do so. Or we may do the equal, and they're a little bit different semantics, but way shorter. It will not throw an exception, it will return null both sides. Or even functional style, if you like it. So normally you may say it is good or it's ugly. Well, it depends. And to wrap up, the question for you, what is the type of this declaration? So the Kotlin has statically types, so it infers types for every declaration like this. And the type is nothing, question mark. So it's a nullable nothing. So it has the only one value, which is nothing, and that is it. And so if someone would ask you, but trust me, you would explain it. You may say that nothing would help you to clean your code. If you say so, please explain to anyone what it means. Because the meaning is not obvious, is it? OK. Well, here comes yet another fact. Or in Kotlin, you may implement as much interfaces and a base class within the same anonymous object. You do it this way. And if you do so, and this declaration is private, you can access anything inside this object, which you declare there without overrides or something. But only if this declaration is private. It helps if you deal with some callbacks or complicated things. It just helps you to write less code. OK. But implementing an interface, it's an obvious thing, right? We implement interfaces all the way, all the days. And how would we implement interface without actually implementing one? Do you have an idea? Well, I have an interface to implement. And there are frameworks which do this for us behind the scenes. So we create an interface. We say, oh, the framework, could you please give me an implementation of that one? Say to do some network calls, or to do some REST, or to do some anything. Well, this is the one thing I selected to explain, to show. This is the standard thing in JDK, which is Java lang reflect proxy. So this is their thing. So you can pass their parameters and the invocation handler and the interfaces which you would like to be implemented. And this one, behind the scenes, would generate the bytecode, would load the class for you. So you'll have an instance of this interface without explicitly implementing that one. Sometimes it makes sense. Some frameworks do use it. Let's see how it flies. So we implement the invocation handler, the standard way. And then we see the gray highlighting. So we shrink it a little bit. We use the same constructs. So if you have a functional interface from Java, you can implement it as a lambda in Kotlin this way. You can even use the underscores to hide the parameters because they are not needed here. And my intent here is to throw you an exception. So I throw exception to say, oh, well, this is an intent. And now I have the implementation of the handler, implementation of the proxy, and finally I do the call. So the question, what would be the outcome of this? Will it work? So yeah, sure, it has to work, right? Obvious. So I call this doJob method of my service. It goes through the proxy to the handler, and handler throws me an exception. What can go wrong here? Well, actually, something could. You will see this exception in the outcome. And why? The reason is that the Java lang reflect proxy tries to follow the Java language specification. And as long as the service exception is not a runtime exception, it has to wrap it into some specific runtime exception to avoid breaking Java. Fair enough, that's good, that's right. The fix is obvious again. You'll spend some years to figure out why, but then the fix is clear, is it? And to clarify is that, well, the proxy uses, and there are many cases in your code base and there are your libraries which may do some proxies. So if you're uncertain in how it behaves, give it a try, take a look, figure out what's going on inside before you'll have the troubles like this. Right? Okay. The next fact in the list would be generics. Well, do you use generics? Yeah, because we are not doing Go, right? Well, so as for generics, have you ever tried and know how generics are implemented on top of the JVM? The fact is that generics has type erasure. So all your fancy generics are being erased at the moment where you have the bytecode for the JVM, right? Well, let's consider an example. So I have a function which takes type parameter, and I require that the type parameter implements both number and runnable. Examples is hard, right? But never mind. The fact is that we call the runnable here, and we call to double from number. And now I do the following trick. So you could do the same trick with Java, or you can use a Kotlin here. What I do, I ask the Kotlin compiler to compile this thing into Java bytecode. Then I ask the Java decompiler to decompile it as the Java source. And the outcome is this. So the first thing, of course, Java decompiler takes hard to understand the Kotlin code, but sometimes it gives us their representation which we're able to understand. Well, the first thing is that the type parameter has gone. It's a number, not number and runnable anymore. The generic return type is gone as well. It's now only a list. And here we have a cast. This is how the type erasure works, and this is what we have at the bytecode level. So the compiler, both the Kotlin or Java, they use casts inside because they can prove that anything is right, and then they use cast inside where necessary to follow the intents what we have. Well, this is what, and sometimes even more, sometimes the compiler is able to generate some bridge methods for you to make sure that this generic thing looks as you expect it to from one side, and it has the base methods as it should have because of their upper bound. So every type parameter is replaced with the upper bound, which is object in most cases, or something you specify, like in my case, the number. Well, as for workarounds and the things, if you try to cast to T in your code, make sure you understand what's the magic behind it is. Sometimes class.cast is the best thing to use. Well, or you may use the Kotlin redefined generics. So I have an example for you. So I have the first one, the hockcast, which does something which IDE highlights as, well, it's probably not the best idea to do. Well, in the second one, there is no highlighting, no problems. This is an inline function with a magic redefined keyword here. Let's see what it goes. So I have a test expressions. So I do the first one with a hockcast, and the second one with a refined cast. And both calls has to fail because I pass a string and expect integer, right? So, and guess what? The outcome would be really interesting. The first one would not fail. The first one is fine because once you compile it to the bytecode, types are erased, and you no longer have any cast in the hockcast. It takes object, it returns object. What it does some null check. That's useless for our example, right? So if you see here, it's all fine, it would go through. Whereas the inline redefined function will be inline to the call side, so that the cast to int will be here, and it would fail. This is something we would expect, right? And in the longer run, if you have a generic and generic and generic and generic kind of thing, it might be a trouble if you do such a cast to T somewhere underneath. It might take some time for application to crash, which is surprise, actually. As for inline functions in Kotlin, if you have an inline function and you pass a lambda inside, this lambda would be inlined in the call side as well. So that if you, for example, deal with the collections in Kotlin, if you do map or flat map or flat map or anything similar, well, it will inline your lambdas so your code would not have any object creations inside beyond the collections. Well, a redefined type helps as well. So for example, here you may create a deserialization library, which behaves this way. I create a function load, and I have an anonymous class inside this inline function. So it would be generated for every type parameter, every call side. And then I can say, okay, load, and here I would expect it to have this type list from map from blah, blah, blah. And here I say, okay, I would like to load the list from strings. And it is possible with refined generics, and it is really harder to implement with a plain, say, without it. Like the type reference from the Jackson library or kind of stuff like that are intended to be helpful in a generic case. Well, the last thing to show, this is a tiny pattern to create a logger, because all the time I create a logger, I don't like to write the same class name twice. They're for the class name and for the logger. So it could be used like this. And if we go and see the generated bytecode, we'll see something like that. So in this case, the logger is created from the class logger, and the Kotlin compiler would take care about passing this one into that one. And I no longer need to write the class twice, because if I would copy, paste my code, sometimes I might forget about the change in the logger, well, for the unexpected results in my program. Okay. This was about the generics, and now it's time to jump into coroutines. Have you ever tried the coroutines, by the way? A few hands. Okay, thank you. I'll be speaking coroutines in more details later today, so if you would like, just come by. And today I explain something interesting again and unexpected about the coroutines. This is the library which helps you to deal with coroutines. This library is that huge, so I failed to put there all the modules which it has in this slide. From the other side, it's pretty awesomely documented. And it supports as much features as possible to deal with it. Channels, select expressions, flows, reactive extensions, anything. So if you would like suspend functions and you would like to have a readable code, well, it's something to do. Well, and here's an example for you. Do you like functions with the callbacks, by the way? Okay, I don't like them. But it's complicated because you're trying to push the brackets to the right all the time. Well, and here's a solution to turn a function with a callback to the function without a callback. What do? You write this amazing thing. This is a standard library, and this is a function which is suspend coroutine. This is a tricky function which takes the call stack, and it allows to replace this call stack with a callback. So once you go through, you say, okay, I'm done here, and you have a callback to resume the computation from that point. And the time between you've done and you call the callback is free, so a thread is able to do whichever it likes. It's not forced to wait for you to resume. And then you subscribe that one, and you call resume to continue the execution back. So this are the solutions. So, and this was the suspend function, which is not good. And now we have an ordinary function which does run blocking and calls this function. So overall, the example is as follows. You do run blocking, which says, okay, we need to run some suspend functions inside to wait for it to complete. Then you say suspend. Then you call your function, and you pass this resume as a lambda to the original one, right? As far as you do so, you finally have the function which does the callback magic, which calls the function which does the callback magic, but this is an original function now. This is a tiny pattern which can be used. Well, as for callbacks, so you use the suspend coroutine or suspend cancelable coroutine to suspend execution and wait for a callback to happen. You use run blocking to wait for the whole thing to complete, and it blocks your thread to wait for it. But lastly, it is something easier to code, I hope, because here you just say, okay, I just write this snippet and I'm done. But don't trust me, trust your profiler, because sometimes this may work a little bit slower than you expected it to, right? Well, the second example here is the recursion. I decided to do this recursion thing, and if I start this one, well, I'm likely to have the stack overflow, right? That's fine, because I call this function on and on again 100,000 times. Well, how do you solve the stack overflow? Or beyond the first two hacks, well, you may use a tail recursion in Kotlin, so this tail rec function, but it requires you to have the recursive call be the last call of the function, so it turned out to be tricky. The second way to solve the recursion is not to use recursion, right? So you can rewrite your code in a way that you would use the queue or something else to avoid the recursive calls, right? That's the standard solutions, but these are really hard, and you spend your time thinking and manually hacking it. And here's the trick for you. I added only 2 magic words in this example to avoid the stack overflow. The first one is a suspend keyword at the top, And the yield function in the button. What does the yield function? It suspends the execution, so instead of the call stack, we have a callback and a heap object. Then we queue this object to be resumed in just an ordinary queue. So essentially, behind the scenes, we have the same queue as you may have created for your Stack Overflow thing, right? But it is done by the compiler for us, so we don't need to waste our time to write this. And to call the suspend function, I use run blocking here because you cannot call the suspend function from an ordinary function. And that is it. It works. Well, so yield allows you to exchange the call stack with a callback and the queue this callback immediately to be executed. The run blocking thing is a thread-safe thing to wait for all the suspend functions to complete their work. And again, this is easy to code, but don't trust me, trust your profiler, because sometimes it's really easy to hack that way, but it may not perform in the way you expected it to. But it's not only for the coroutines, actually. Sometimes it's for anything we write. It's good to profile it to see whether it's fine or not that fine, right? Well, if you would like to learn more about coroutines, here's 2 videos, and I'll post the slides later on today, so you can take a look at these videos and see how coroutines are being used in the real cases, not in these fancy cases. Okay, and to wrap up, I would share you yet another story with an experiment. So if you do an experiment, if you do a try to something new, well, you may do it with Kotlin. This is something I've done so far with the game of life. That's the Conway game of life. It's a game which works on a 2-dimensional space. Well, you have a cells and you have a rule how the cell changes the color. This was something that Conway invented learning about the biological systems. And it exhibits really interesting behavior, but the rules are local. So we say that, and the rules are these. So we say, okay, the cell is alive, one color is alive, the second color is dead cell. The cell is alive if it has 2 or 3 alive neighbors, and otherwise it's dead. And the dead cell can become alive if it has 3 alive neighbors. That's all. All rules are enough to define this interesting behavior like this. Well, I decided to write this program like this, so I created the maze, I created a function to run the evaluation, and I print the results. And I decided to use Unicode to render results nicely, right? And this one is a favorite glider pattern, so this would go to the right and bottom with the next iteration like this. But it was an experiment. I was having fun to implement something really interesting and to see the dynamics, because if you would start with random colors on the maze, it would be changing all the way along. Well, it was a tiny program at the JVM. And then I decided to see, okay, can I create a binary out of it? Well, sure, I can use the growl or I can use anything else. But I decided to create a binary with a Kotlin. There is a Kotlin native which is able to generate a binary for me. And this is the way, for example, to run my code in iOS. So I created a binary which is 1 megabyte long. It doesn't require any virtual machine to run. It has its own GC inside. Well, so I was able to do it. And it was an executable which I can ship, or I can compile it as a library or as a framework. I can interrupt with a Swift if I need it. But the fact is that the same code base which I had before can be used over here as well. Well, then I realized that if you have an application, if you have something, well, why couldn't I use the browser to show it? And it turns out that the browser console is really good to deal with the Unicode from one side. From the other side, I used the same code as I had at the very beginning, so I spent less time on writing this program, and I spent more time trying to run it on all the platforms. So I could do it this way. But, well, if you do so, you realize that in the browser, you can deal with the HTML and a canvas, right? So I decided to give it a try, and I used the DSL for HTML to create the browser web page. It is not React. It is pretty simple thing. This is Kotlin X HTML. This is libraries on the GitHub. What it does create 0 buttons for me and their canvas to render the image. And I even have on-click handlers here to say, oh, let's do something. And there's a reaction on that given click. That's it. Well, so far I was able to create the thing like this. And I still use Unicode here, and then I decided to deal with the canvas. And the thing is that you can use Kotlin JS. You can deal with the JS from your Kotlin. So you don't need to write JS code to deliver a JS application anymore. And well, if you hide any math here, the canvas rendering is pretty easy. So what I do, I just have the canvas of the given type, which is pre-imported in the Kotlin standard library. And then I say, okay, let's draw ellipses of a given ratio and the size and the given coordinates. And that was it. So I was able to render the same thing in the browser in the canvas easily. The same algorithm is now running in the browser. Well, at that point, my son came to me and said, oh, you're doing interesting bugs here. Well, and I decided, okay, I can create you an app for an iPad to give it a try. And well, I decided to think about the mobile. And there is for mobile, I can use the Android for it. Just compile the same code, just put it into Android Studio, and I'm done. And I decided to give it a try in iOS, because it's a native, it's different, and it was fun for me to give it a try, right? Well, I use a Kotlin native again. And the fact is that I compile my Kotlin code, the same code snippet, actually, the same from the very beginning. I compile it as the framework, and I include this framework into Xcode to deal with. This is about it. So the picture could be like this. So you have their common part, you have the specific iOS part. In my case, I created a tiny wrapper in Kotlin. And this is a framework, and you can give it to someone who knows how to deal with an iOS, and you're done. Well, turn out that Xcode console is really good at rendering the Unicode symbols, again. But it is not something you can ship, right? You'd like to ship an app. And I decided to go further and ship an app. So I decided to render the Unicode symbols inside the iOS app. Well, the easiest way, the easiest solution, the first prototype, sometimes it's enough, right? And well, I wrote the following code. So I wrote a tiny wrapper in Kotlin to generate the maze. And it has this, the callback, which is the lambda in Kotlin, which returns me a string, which is the representation of the maze. Every time I do some action, so this wrapper has the method like next step, next step. It computes the next step, and it kicks out the callback when I need to update my UI. And the funny fact is that the bottom part is written in Swift. So what I do here, I create a lambda in Swift. This is the whole thing is a lambda written in Swift. And I pass the Swift lambda as a Kotlin lambda. This is how interop here works. This is the way to combine two words and the benefit from every of these worlds. That was it. So finally, I was able to deliver an app in extra 5 minutes or 10 minutes from the beginning. And this app was able to work on a mobile device, and a native mobile device, actually. Well, to tell the truth, while I was preparing this presentation, I realized that I was looking for this really nice animation from the very beginning. And from the other side, I was having a need for a web server to show my JavaScript, because the browsers are normally they're happier if they download something from their HTTP, even if from a localhost, rather than using some local files. So I created a tiny web server for it. And in my case, this web server was the cater.io. This is a web server which is done by JetBrains, and this one uses the coroutines and the suspend functions from Kotlin to deliver the best possible performance. And it starts like in 100 milliseconds or so. So really easy to give it a try. And then I implemented the rendering in AWT. Well, it's nothing complicated in here. So you do something like this. And then I was able to generate animated GIFs from this web server. And as for animated GIFs, it's good that the standard library of Java, it contains anything you might need to render their animated GIFs. So if you're able to render it to a buffered image, then you can wrap zero buffered image into an animated GIFs. So this was the way how I was able to generate these GIFs, which I'm showing you right now. And this is amazing how the behavior of these dots is implemented. and it's working. It's really interesting, the model to model. Well, okay. So to summarize, if you would like to see, open it on my GitHub, take a look. This is a small project which supports the multiple targets. So it uses the Kotlin multi-platform projects. This is the MPP, this is the hidden keyword to Google for what is possible with Kotlin. If you would like to write the code once and then deliver it to different platforms, say including the JavaScript, including their server-side, including their mobile, both iOS and Android. And well, to summarize, I have this picture for you. So you can, with Kotlin, you can write the program in Kotlin for your server side, for your client side, for your mobile device. You can even have your build script written in Kotlin, which is Gradle Kotlin DSLs. I do recommend using this because it allows you to understand what's going on inside your Gradle builds. Because if you have a navigation, you can drill into the sources of every plugin you have so far, and you can see what's inside, how it works. And in most cases where you do something wrong, you will see the compilation here instead of a random misbehavior. Well, and it's probably the last thing I would like to share with you. It's something about JetBrains and Kotlin. So we started this language to create a language which we would have fun and a pleasure to working with, to develop our applications and tools. And we do use it nowadays in mostly everything here. Like say in TeamCity. On TeamCity we use Kotlin to do their build pipeline DSLs. This is a way to write your builds in a complicated, huge builds with a Kotlin inside. So it's type safe. You understand what you're doing from one side. From the other side, it is pretty readable to see what you're actually trying to achieve. This is the benefits of trying to create the DSLs. And actually, the Kotlin language is turned out to be designed in a way that it's really friendly to allow doing the DSLs. And I would probably explain you one more thing here. This is a rider. Well, it's Java conference, but you may probably heard something about the C# development. And the rider is the cross-platform .NET IDE. And the fact is that the rider, from one side, it uses the .NET written ReSharper behind the scenes as their main thing, as a daemon, and it uses IntelliJ platform, which is Java, as the UI. And the whole code base from the IntelliJ platform to a really available cross-platform .NET IDE, this whole code piece is written entirely in Kotlin. So the team decided to use Kotlin and C# to develop this product. And there are many products which we have at JetBrains, and just like this picture, there are many things. And almost everything is using Kotlin, more or less. It's actually depending on the team, where they eagerly use it, where they a little bit more conservative in using Kotlin, but they use it everywhere. Well, it's yet another fact is that the ACM ACPC contests, it's the third year where their competitors are allowed to use Kotlin to submit their solutions. So if someone would be taking part or took part in this, now it's possible to write your submissions in Kotlin. And there are other websites where you can compete or like the practice in their ACM, ACPC contests, which supports Kotlin along the way as well. Well, and to wrap up, these are keywords which you have in Kotlin. So if you would do the multi-platform programming or MPP, you are likely to write expect fun. And you'll probably expect fun doing so, right? And this comes, another fact. I guarantee you that you'll see these lines in your program if you would try doing MPP. It would be an actual fun, I guess. So, have fun, give it a try. And I'm here, so come by the JetBrains booth or here, and I'm happy to handle your questions. Thank you for your time.